So welcome everybody to session 3 of the Near Web series. Today we're going to be going over accounts and transactions. My name is Troy Bossard. I'm the vice president, co-founder at the University of North Florida Blockchain Club. Joining us from UNF today are Cutter Naismith, Natasha Interlicia. And also we have Jason. I see Jason in the crowd there, maybe a few more other students as well. So yeah, Near Web series session 3, hosted in partnership with Blockchain Acceleration Foundation, where we are going over topics specific to the Near ecosystem, as well as some general blockchain topics as well. Yeah, so today we're going to be talking about accounts and transactions. We are going to first start off talking about accounts in the first half of the presentation. Then we're going to have an opportunity for any questions from the chat that anybody has. We're going to try to answer those as it relates to accounts. Then we're going to move into the transaction section. We'll have another opportunity for Q&A at the end of that. And then we actually have an exciting activity planned. We're going to be funding you guys for the creation of new Near accounts and Near wallets. So that'll be something we'll do together after the conclusion of the main part of the slideshow presentation. And from there, we have a special guest speaker, Matt Lockyer, who will be introducing after the account creation activity. We're really excited to speak with him today. So thank you everybody for joining, and we're going to go ahead and get into it. All right, first part, accounts. So we're going to, when you're talking about accounts, you have wallets, accounts. We're also going to be talking about contracts and how they function with regards to the Near protocol. We're going to be talking about keys and key management on accounts, which is a pretty unique aspect to Near, I would say, as compared to other blockchains. So first, we'll talk about what is a wallet. A blockchain wallet is a digital account that allows users to store and manage their Bitcoin, Ethereum, Near token, and or other cryptocurrencies. There are two different general wallet types. The first wallet type we have is a custodial wallet type. And a custodial wallets basically have the private keys, aka the ability to move money delegated to the wallet provider on behalf of the user. And by nature of their design, users may not even have access to their own private keys. So you're delegating the responsibility to permission the transfer of money to the wallet provider. This is something like a centralized, like a Coinbase, a wallet that is held by Coinbase on Coinbase Exchange or other centralized exchange wallet solutions. The second type that we'll be talking about is non-custodial wallets or self-hosted wallets. These have the access to private keys retained to and kept secret by the user themselves, aka you. So this allows you to transact in a permissionless manner with blockchains and with blockchain applications. This is similar to the way that the Near wallet functions on the Near blockchain and ecosystem. Now we're going to talk a little bit about what is an account on Near. So it's a little bit different than other blockchains. Each account on Near is a smart contract itself. And rather than having one private key per account, like would be the case on Ethereum, on Near, you can create multiple keys on the same account. And Near utilizes a human readable addressing system, aka you can see in the graphic below, the example below, you have Robert.Near versus an alphanumeric string as the account ID on Ethereum. Here, we could dive a little bit deeper into some of the differences between Ethereum accounts, which some of you might be more familiar with, and then how that compares to accounts on the Near protocol. As we said before, the Ethereum account, you have the public identifier, which is an alphanumeric string. You have the human readable version for Near accounts. You have one secret key per wallet on Ethereum, whereas on Near, you have multiple key pairs or no key pairs, but you can do multiple key pairs with varied levels of permissions depending on the access key type. And so for the Ethereum wallet, if you hold the key to the Ethereum wallet, you have full access, and the account on Ethereum does not need to be created via transaction. Whereas on Near, you have permission-based key pairs, and the account ID must be created via a blockchain transaction. Here's some of the rules to account creation on Near: minimum 2 digits, maximum 64. The account IDs on Near are comprised of account ID parts, which are separated by periods. So in this example, the account ID parts would be NFTs, Robert, and Near, or another example, tokens would be the account ID part, Robert, another one, and Near. So that brings us into a concept in Near protocol, which would be sub-account models and top-level accounts. So on Near, only the direct parent can create a sub-account. In this example, Robert.Near would be the parent account, or would be the parent account of token.robert.near. So Robert.Near creates token.robert.near. Token.robert.near can create bridge.token.robert.near. And Robert.Near itself is actually a sub-account of .near. So all mainnet accounts use a Near top-level account name, aka Robert.Near, and test accounts use a testnet top-level account, Robert.testnet. For account recovery, this is something that's interesting with the Near protocol. There are more options for account recovery and backup than just a recovery phrase. Although personally, I recommend using the recovery phrase. It sits clearly in the most secure in the most secure section. So you can use a recovery phrase, aka seed phrase, and this is something that you should write down, ideally physically. There's a lot of different ways you can store it securely, but you want to store it securely so that you can access your account in the event that you lose access to it through your normal means. You'll be able to recover it. Near protocol also has Ledger hardware wallet integration. The hardware wallet basically is a physical key management solution. And then you have also some interesting other ways in which you can secure your account for account recovery using things like a phone number or email, which a casual blockchain user, this might actually make blockchain seem more accessible for the average person, being able to interact with a blockchain and do account recovery through ways that they're more familiar with, aka with a phone number, an email, something like that, that you would, the same way you would with other services in Web 2. So every account on Near is a smart contract when it's first created. Each Near account can only hold one smart contract, and sub accounts, as we mentioned, can be created under master accounts for applications in which multiple smart contracts would be deployed. So this can be useful for organizing an ecosystem of contracts for a particular application. So for instance, you might deploy a contract under user application.near, and some subcontracts within that ecosystem could be named contract.1.user application.near, contract2.user application.near, et cetera, et cetera. And this could be basically a contract management solution for a decentralized application that you might be thinking of launching on the Near protocol. Near protocol also has implicit accounts, which allow the reserving of an account ID before it's created by generating an ED25519 key pair locally. ED25519 is an elliptic curve signing algorithm, which is similar to ECDSA, the elliptic curve digital signature algorithm, which is utilized in many other blockchains. The key pair has a public key that maps to a 64-character hex representation that then becomes the account ID. Here you can see some examples of what that might look like. Whenever you create an account in Near Wallet, before it's funded or before you choose your human readable account name, this is kind of what it's going to look like. And then once you fund your account, then you can choose your Near name and it becomes a human readable account name. There's also dev accounts on Near protocol. These are special accounts that are made by the Near command line interface in Near Wallet. This helps with the automation of testing and deployment of contracts. This is something that exists on the testnet. So you may be wondering, what kind of account data is stored under the account data structure for Near protocol. The data for a single account is co-located in one shard and consists of the following different types of data. You have the balance, for the account. You have locked balance, which is related to staking. You have the contract code if a smart contract is deployed to this account, and each account is a smart contract, remember. Key value storage of the associated contract. Then you have information about access keys, of which there can be 0 to many, with either a full or function call access designation. This is something we're going to be talking about a little bit more in the next couple of slides, full access and function call keys. It also contains information about postponed action receipts and received data receipts. We're also going to be talking about receipts as well, which is an interesting topic for Near. So first we'll talk about full access keys themselves. So a full access key is basically administrative privileges for a given account. Full access keys can create new accounts, delete accounts, add or delete keys, deploy contracts, call functions, transfer near, handle stake. They can even create other full access keys as well. So you can have multiple full access keys on the same account. So administrative privileges, very powerful method of permission keys. So, and then that takes us to kind of an actually really interesting implementation of permission keys on Near protocol, and that's with function call keys. Function call keys grant limited permission to make a function call to a specified receiver ID and methods of a particular contract with a limit of allowed balance to spend on gas. So you can pre-allocate gas to a function call key, and it can only call smart contract methods that don't attach Near token as a deposit. AKA function call keys can only call non-payable functions because ones that do attach Near token would be payable functions. There are 3 attributes that are important with regard to function call keys. That would be the allowance, which requires approval for transfer of Near, the receiver ID, which is the contract that the key is allowed to call methods on, and the method names, which is the methods that the function call key is allowed to call. Some of the perks of having function call keys, it's really a powerful usability feature. It opens up a lot of different possibilities with how users can interact with smart contracts on a blockchain. They don't need to authorize small transactions over and over again necessarily. It can allow a user to interact with a blockchain, as mentioned before, without even creating an account, which is actually a really high barrier of entry for a lot of people, creating and funding an account. So if you can interact with blockchain-based applications without even having to create an account, that is potentially actually provides a lot of utility for people in certain contexts. And this also provides, for more specifically, the ability to more easily implement something like near real-time blockchain gaming. You may be wondering a little bit about access key storage and sign out. So Near uses human readable account names instead of a public key hash, partly because many key pairs can be created for individual accounts. And Near uses account access keys Near account access keys for Near Wallet are actually stored in your browser's local storage. You can use browser dev tools to clear, that or interact with that. If you go to your Near wallet and you inspect the page and go to applications, you can actually see information about the key stored within your browser's local storage. And as I mentioned previously, we're actually going to be doing an account creation activity together. But here are some of the links that you can use to create an account on mainnet. It's wallet.near.org, betanet, wallet.betanet.near.org, testnet, wallet.testnet.near.org. In order to fund an account on Near, you need 0.1 Near. This is for mainnet specifically. You need 0.1 Near to start an account, and that will be funded by another account. You can buy it on an exchange and fund it from there. Get one of your friends to send you some Near. You can also use Near's command line interface to create accounts as well. Just a little context about the differences between mainnet, betanet, and testnet. The mainnet, obviously, the main Near network where all the hardy live applications live. This is where most people will interact with the Near ecosystem. You have betanet, where new changes are trialed before being moved to mainnet, and the testnet, where most of the development takes place and it's okay for things to break and go ARI. Yep, so that is the end of the accounts section of the presentation. I'm going to go ahead and check chat and see if we have any questions or anything like that. Okay. I don't see any questions in chat. Feel free to type them if you have one about the account section. I can always circle back as well after the next section. All right, so that takes us into the transactions section of the presentation. Got a good idea about how accounts work on Near. Now we're going to talk about some of the nuances of transactions in the Near ecosystem. Some important concepts when you're talking about transactions on a blockchain, you want to know how to use the transaction explorer for sure. I use that all the time for every blockchain that I interact with. I'm always looking at the transaction explorer, exploring, checking the status of my transactions and things like that. Receipts are an interesting topic, which we mentioned we would be talking about previously in this presentation. Receipts are interesting on Near. Gas, super important concept to get. And then Near is a sharded blockchain. So there are some interesting differences in how transactions are processed under sharded blockchain models, as opposed to non-sharded blockchains. And we'll be talking about sharding a bit as well. So if you're wondering where you can view transactions on Near, you can go to explore.near.org. Here you can see some examples of what type of information you're able to see in the Near Explorer. You can view the current number of nodes, the total number of validating nodes. You can see the block height, transactions for 24 hours, as well as a list of a running list of transactions, which include things like contract calls and execution, as well as strictly value transfers, i.e. the exchange of Near tokens from one account to another. You can see the average block time is 1.2 seconds. So that's about how long you could expect to receive your first confirmation whenever you send a transaction on Near protocol. You see kind of on the bottom right, you can see, a transaction, or sorry, the 14-day history of transaction volume. Let's take a closer look at an individual transaction. So here we have a transaction that I just randomly, whenever I was putting this together, randomly pulled it from the Transaction Explorer. Thought it would be fun to take a look at. So it contains information about the signer, the receiver, the transaction gas fees, the gas attached and burnt, the block hash, and even the argument that was passed to the contract call, which is what the transaction consisted of in this case. If you look at the receiver ID, you can see that the call is made to something called NearCrowd, which interestingly is an application on Near where people can complete tasks in exchange for being rewarded in Near token, which I thought was interesting. Kind of reminded me of Google's Mechanical Turk a little bit. This particular transaction appears to be passing an argument as a solution to some task being completed by the signer who is jinx.near. And you can see there's some information and a solution hash included for something called task ordinal. Let's move on to receipts, which are an important concept to understand in regards to how transactions are processed on Near protocol. So all cross-contract communication in Near happens through the issuance of receipts. When we talk about processing a transaction on Near, this eventually means applying receipts at some point. A receipt basically is a paid message to be executed at the destination, and a transaction is an externally issued request to create a receipt. So basically, receipts are created as paid promises to finish the execution of a broadcast transaction. Now, when I say that, I'm actually specifically referring to action receipts, which are one of the two main types of receipts on Near protocol. So the action receipts represent a request to apply actions on the receiver side of a transaction, and they can be derived as a result of a transaction execution of another action receipt processing as well. So action receipts can generate more action receipts, and so on and so forth, until the complete execution of a transaction, at which point a data receipt is generated. So data receipts are more like what one might think of as a receipt on Ethereum. Basically, it represents the final result of a contract execution and contains information about the final result of a transaction. Some information about signed transactions. So a signed transaction is what basically a node receives from a wallet through a JSON RPC endpoint. The RPC is what you, whenever you're using something like MetaMask, or in this case, or in the case of Near, maybe you're using Near Wallet, whenever you send a transaction, you're doing that through an RPC endpoint. The RPC endpoint then sends a signed transaction, and that's what the node receives through the RPC. And this is routed to the shard where the receiver ID account lives. The signature, aka hence signed transaction, the signature proves the ownership of the corresponding public key and proves the authenticity of a transaction itself. So that's how you know that a transaction, if it's signed, that it has been properly authenticated and it has permission. So you may be wondering, how are transactions validated and errors checked on the Near protocol? Well, there's basically two steps that it goes through. The first step is called basic validation, where the initial validation of a transaction, that is, the initial validation occurs of a transaction received by the network. And the important distinction here is that basic validation does not check the state of the blockchain. It checks for things specifically such as that the signer and receiver IDs are of the valid format. It checks if the transaction is signed by a public key and other non-state dependent checks. Once basic validation is done, then it moves into validation with state, in which it checks the transaction against the things that it has to reference and check the state of the blockchain for. Things such as whether the signer ID exists, whether there's enough balance to execute the transaction, whether the person who is calling, sending the transaction has permission to call the function and contract that it's attempting to interact with. So that's just some information about how transactions are validated whenever they're first broadcast. Another really important concept to understand in the context of blockchains is gas. So we'll kind of give a brief comparison actually, and that highlights why gas is actually kind of an innovative thing. Some people hate paying gas fees, and actually gas fees are really low on Near, by the way. But gas is actually kind of an innovative solution to a problem of application persistence on the web. In Web 2.0, developers themselves pay the cost of cloud, the business developers pay the cost of cloud hosting upfront. And this leaves the possibility of applications and businesses going down. If, the business goes defunct and they don't pay their bills for hosting anymore, the application can go down and it can disappear. With Web 3.0, users pay when they make a call to the application, meaning that applications actually have no long tail risk of going away due to the developer company funds running out. And this is because of, in part due to gas fees. So the cost of hosting is paid for whenever someone wants to use the application, basically. In some sense, applications on blockchains are permanent, but gas is an important part of keeping blockchains up and running. So that's how that works. It allows for very persistent applications. Calls to read data generally do not require gas, but changing state does require gas generally. So some calls require gas fees, and other ones don't require gas fees. It just depends on whether you're changing the state of the blockchain or not. An interesting thing about gas on Near is that gas prices are deterministic on Near, meaning you cannot pay extra. And this differs from Ethereum in that on Ethereum, you can pay more gas on a transaction to have it processed faster. This results in gas competition, in which during times of high network congestion where people try to outbid themselves, and the cost of using the network for someone who's not interested in the latest flashy NFT drop, they're just trying to do the thing normally, can become very difficult at times on Ethereum. Gas prices on Near are deterministic. If you remember back to the example transaction that I showed earlier during the part where we were talking about the Near Explorer, the transaction we showed specifically included 30 teragas with the transaction, but it only used something like 8 teragas. So the excess gas would have actually been returned to the user in that instance, which is pretty cool. And here's another concept. We actually talked a little bit about prepaid gas earlier when we were talking about function call keys. So basically, prepaid gas is an interesting thing on Near. Developers can allocate gas for first-time users to draw from when interacting with their application. So this allows for easy onboarding and interaction with near contracts without even needing to have a near wallet, which is a pretty interesting way to interact with blockchains. So using function calls, your backend can create a new access key for a user on the contract's account, which the user can then use to interact with the contract. So developers can set allowances on access keys that correspond to specific users, i.e., maybe one function call access key per new user with a specific allowance or something like that. So that wraps up the gas section. Now we're going to start talking about something that's like kind of complicated a little bit, but not really. And that is sharding. So sharding is a blockchain scalability solution. There is an issue with blockchains in general, in that they can be slow and expensive to use. Sharding attempts to solve both of those problems while maintaining an acceptable level of decentralization and security. Basically, sharding it splits the state of the blockchain into smaller partitions, or like little blockchains, where each shard has its own data. And as I mentioned, the purpose of this is to increase scalability and throughput of blockchains to be able to, onboard more users while remaining relatively cheap to interact with. But this does add challenges related to the security of individual shards, which is kind of outside the scope of this presentation. But basically, it potentially can split up the security into partition segments that can be easier to attack in certain instances by malicious actors. So the most common way that sharding is implemented is utilizing something called beacon chains. So beacon chains, basically, you have the beacon chain and you have different shards on the blockchain. The shards are chugging along, processing transactions, and then at some regular interval, they pass information back to the beacon chain, and the beacon chain performs some regular housekeeping functions, which is proportional in size to the number of total shards in order to keep everything in line. This creates sort of a bottleneck and potential scalability, but as I note at the bottom of this slide, the needs of blockchain users are not currently projected to outgrow the potential scalability of sharded blockchains. We're not even close to that limit whatsoever. But I just thought it was interesting to note that this could create bottleneck issues on sharded blockchains in the future. The interesting thing about this type of implementation is there's a multiplicative effect to arbitrary increases and improvement to sharded networks. By the way, this is not necessarily a method that Near protocol uses. I just thought it was important to talk about in the context of sharding. We're going to talk more specifically about how Near implements sharding in subsequent slides. But with quadratic sharding, there's a multiplicative effect to arbitrary increases in the improvement to sharded networks. So if nodes operating on the network become 5 times faster, then each shard can process 5 times more transactions, and the beacon chain can then maintain 5 times more shards. So the throughput across the whole network increases by a factor of 5 by 5 equals 25, thus the name quadratic sharding. Here we have a graphic that compares this is more just to kind of show you what the beacon chain looks like. We're about to talk about near specific sharding, and then we're going to circle back to this graphic in a few slides as well after we talk about that. So here you can see there are the smaller blocks. There would be the individual shards. They're chugging along, producing blocks within their own shards. And then at regular intervals, as you can see by the dashed lines, they pass information back to the beacon chain, where those regular housekeeping tasks and checks are performed in order to maintain consistent consensus across the network. Here you can see Nightshade is modeled as a single block. It uses something called chunking, which we're going to talk a little bit about in a second. So let's move on to the next slide. So Near uses something called state sharding, which is an approach to sharding in which there's sharding of the state specifically, but which also tends to imply sharding of processing in the network. The state sharded nodes build their own blockchains containing transactions affecting the local part of the global state assigned to their shard. This linearly reduces the requirements on all computing power, storage, and network bandwidth. Hence, some of the additional scalability that's offered through this implementation. However, state sharding does introduce some problems with data availability and cross-shard transactions. Near specifically uses a unique implementation of sharding called Nightshade. So basically in Nightshade, the blockchain is modeled as a single blockchain as opposed to the beacon chain model where you have shards, which are basically their own individual blockchains. In Nightshade, it's more of a single blockchain in which each block logically does contain all the transactions for all the shards, but no participant downloads the full state or logical block. Instead, each participant maintains the state that corresponds to the shards that they validate transactions for, and the list of all transactions in the block are split into sections called chunks. Nightshade uses heaviest chain consensus with a Byzantine fault-tolerant finality gadget built on top. And this kind of provides some of the best of both worlds in terms of longest chain consensus and Byzantine fault-tolerant consensus. It kind of attempts to gain some of the benefits of both of those things. That brings us back to the beacon chain versus Nightshade. You have the beacon chain model, individual sharded chains that refer back to the beacon chain. The individual shards kind of act as their own individual blockchains. With Nightshade, you have a single blockchain in which the shards validate chunks of the total transactions. So that brings us to something relevant to the transaction side of transactions on Near, which would be, you might need to do a cross-shard transaction if the receiver account doesn't exist within the same shard as the sender. There are two different ways to tackle cross-shard transactions. The first one is not implemented by Near, but it's called synchronous sharding. So whenever a cross-shard transaction needs to be executed, blocks and multiple shards that contain state transitions related to the transaction all get produced at the same time. Near uses something called asynchronous sharding, which involves the use of credit and debit shard roles in which a crediting shard executes its part of a transaction once it has sufficient evidence that the debiting shard has executed its portion. And this is something that's accomplished through the use of receipts, which we were talking about earlier. So basically, if a transaction needs to affect more than one shard, it needs to be consecutively executed in each shard separately. The full transaction is sent to the first shard affected. Once the transaction is included in the chunk for that shard and is applied after the chunk is included in the block, it generates a so-called receipt transaction. Those are the action receipts that we're talking about. The receipt is then routed to the next shard in which the transaction needs to be executed. And if more steps are required, the execution of the receipt transaction generates a new receipt transaction and so on. And that kind of circles back to what we were talking about earlier, and that action receipts can beget more action receipts and so on and so forth until the completion of the transaction. Yeah, so that's a little bit about sharding, cross-shard transactions, and transactions in general. Now a little bit about bridging, cross-chain, and layer 2s on Near protocol. The main way to bridge to Near, the most popular way, is through something called Rainbow Bridge. That allows users of the Ethereum protocol to bridge ERC20 tokens to Near protocol's EVM compatible layer 2 solution called Aurora for cheaper and faster transactions. You can do this through rainbowbridge.app. So yeah, if you're interested in bridging over from Ethereum, you can do that through Rainbow Bridge and then, feel free to explore Aurora, which is Near's layer 2 scaling, it's a layer 2 scaling solution for Near. So we got pretty complicated with transactions. We'll just say, let's talk a little bit about just what a transaction is simply. Say you want to send 100 tokens from your account to a friend's. You have to sign the transaction using one of your access keys. This is pretty streamlined if you're using something like Near Wallet. Now the transaction can be verified on the blockchain by the validators. A receipt's generated, which sends the 100 tokens to your friend. When the receipt is generated, it's modifying your account by taking out the 100 tokens. Your friend receives a second receipt, adding the 100 tokens to their account, and the results are generated at the end in form of a data receipt. And then the transaction is done. So that brings us to, that's the end of the transaction section. I'm going to check comments. Okay. All right, cool. Thanks for bearing with me, guys, through that. That is going to be basically the end of the main section of the slideshow presentation on accounts and transactions on Near. I hope you guys learned a lot from that. I know that I did. And that's going to bring us into the next part of our presentation today. We're going to be doing an account creation activity with Natasha. So I will go ahead and stop screen sharing and we will pass it off to her.
Hello, yeah, I think there actually was one question in the chat. I think.
Oh, did I miss one?
Answered it.
Okay.
But
we're sorry, I missed it. When we authorize adapt for say 0.25 for limited access key for each transaction, that is the overall gas allowance for limit. Yeah, for the function call access key, that would be the total amount that can be sent on gas fees. Since gas fees are deterministic on Near, yeah, you would have to, I believe you'd have to create a new function call key. I think that they're spent after use them. I could be wrong, and if that's not true, please feel free to chime in. Anyone who knows better than me. So yeah, that 0.25 Near can only be used for gas fees as well. And since gas fees are deterministic, it'll only use what's necessary for the transaction. Any other questions? Okay, we can always circle back if there are more questions. So yeah, I will go ahead and pass it off to Natasha. Welcome, Natasha.
Hey everyone. I'm going to go ahead and share my screen. So today, like Troy said, we're going to be making our I'm going to walk you through the process of creating a Near account, and at the end, you'll have the opportunity to copy a temporary funding address so that we can actually send Near to your wallet so that you're able to start using it. So we're going to go ahead and go to wallet.near.org to create a mainnet wallet. Go ahead and hit create account, and please feel free to follow along with me. Do get started. And so this page, it will bring you to choosing a security method. You can do the secure passphrase, which is the same thing as a seed phrase, ledger, hardware wallet, or email. I would suggest doing the secure passphrase just because it is going to be more secure. So I'm going to go ahead and pick that one, and you hit secure my account. It'll bring you to a page that looks like this, which will give you your 12 words. And I would suggest writing these down on like a piece of paper or storing it in a secure thing, which I think Troy mentioned it earlier, because if your computer crashes or breaks or whatever, and you won't have access to it if you just have it on like a random file on your computer, and then you won't be able to access your wallet, which is definitely not good. So I'm going to go ahead and copy these for now. I'm not going to use this wallet, so it doesn't matter that you guys are seeing my seed phrase. And then hit continue. It'll ask you to verify the phrase. I'm just going to copy here to see what my fourth word is. The usual. Just type that in here. And then it'll bring you to this page. So at the bottom here, it'll give you the temporary funding address, and we'll send a form in the Zoom chat where you can put that funding address in, and then in the next part of our presentation, we'll be sending you guys the Near so that you can start using your account. And since this is like a temporary funding address, we won't have access to like your account name or any of that, so it'll be completely anonymous, so you can just get your Near and start using it. And with that, I will introduce our guest speaker, Matt Lockyer. He is a software architect and engineer. He is the founder of SoloBlock, and he was also a part of developer relations at Near and Harmony. So how you doing today, Matt? We're super excited to have you.
Hey, I just switched on my video.
Awesome.
So I don't know if you guys want to kill the screen share. Hi.
Yeah, I think someone did. Thank you.
Yeah, just off the top, I just want to say, don't look for anything about SoloBlock Solutions. It's just a personal consulting company. Basically, that's me. It used to be me and some friends, but I kind of went a little bit more independent and just basically me working for companies around the world. I guess I can give you guys a quick, like a 30-second bio.
That'd be awesome.
Yeah, background in just all things technology, pretty interested in visual arts ever since I was a kid, video games, lots of video games until probably my early 20s. Lots of programming, making websites for people, kind of just like hustling on the side as I went through university and stuff. Got out into the real world and basically started kind of being a contract software developer. So I never really got a real job at like a medium or large size company. So I never really worked in an office, which is actually kind of nice. And then I got into to crypto and blockchain stuff. And that was at the beginning of 2017. There was a lot of buzz around Ethereum. It was super, super pumped up at the time. At the beginning of 2017. And then of course, at the end of 2017, if you guys followed the news, it was the prices and everything were really high. So there was a lot of sort of mainstream news attention. And then I've kind of been in the space ever since. So a couple of years in Ethereum, and then I did about 6 months at Harmony. And actually, Troy, I just wanted to give you a shout out. You did a great job explaining everything. Awesome, really good overview.
Thank you.
Yeah, and Troy described beacon chain, and Harmony protocol is basically a beacon-based Ethereum virtual machine running chain, which is to say that there's kind of two parts to blockchains. There's sort of like there's how the blockchain runs, which people typically refer to as consensus, or the networking, or the underlying code that computers around the world will run in order to agree on what the future state of the blockchain is. And when we say state, we mean like basically if all the blockchain is doing is maintaining a ledger of accounts and balances, such as Bitcoin, then that is the state, right? So as it goes from one block to the next, a lot of transactions get processed and the accounts and balances change because people obviously send each other Bitcoin. When we're talking about the state of Ethereum or near, we have to consider something on top of just the orchestration of how these computers agree on the next state. We have to think about how do they actually come up with what the state should be. And that happens inside a virtual machine, which is basically just a fancy way of saying an interpreter for code. So basically, you write some code and you deploy it. Anyway, getting back to the bio, I was at Harmony. It's a beacon chain. So beacon chain is how they kind of did their consensus type of blockchain. So the structure that Troy described with a beacon chain, and it had a Ethereum virtual machine for running code. So that's exactly like Ethereum as it is today. The only caveat with those beacon chains, however, is that as a developer, and I knew this firsthand because I was building example applications on Harmony at the time. As a developer, you have to be what's called shard aware. So you have to kind of know which shard certain things live on. Sometimes that kind of orchestration is handled by the core protocol, and sometimes it's not. So you need to know, like, if I wanted to send Troy or Natasha some tokens, I need to know where the token contract is as a developer. Like I'll first need to find that out, and then my code will have to figure that out. And then we have to basically do a method call from my account to that shard. And then that shard has to increment the balance for Natasha and things like that. So it can become kind of confusing. And that's why I was really attracted to Near's approach to sharding, which is to have like one kind of contiguous blockchain. So from a developer's point of view, we just look at this Near blockchain and it just looks like one thing. And that's great because we don't have to worry about where, Troy's smart contract is or where Natasha's account is. We just go through those human readable names. A Near is like an air traffic controller. It tells everyone where to go and where to fly. So that's really cool. So I saw that. I was at Harmony, and then I moved to Near around I started looking into it around February 2020, and then I started kicking off the interview process like a month or two after that. And then yeah, I actually joined the wallet team on Near. So a lot of the stuff that if you just set up your Near wallet with Natasha, you probably saw some stuff that underneath the UI, there's some of my code is running, which is kind of cool to think about, because there's like, I don't know, it's like tens of thousands of Near users now. I know there's like millions and millions of accounts, but a lot of those accounts are just they're just coded accounts, so they're just bots, right? But there's tens of thousands of real Near users, you know, active every day, which is kind of cool. And then I helped out with the multi-sig contract and the two-factor authentication of the wallet. So that's a way that you can secure your account. I helped out with the code for staking in the wallet. I pretty much was like the main sort of front-end JavaScript person for the staking portion of that, and the two-factor stuff pretty much. But yeah, so that was it. And then I joined the developer relations team at Near. And at the time we were sort of post our mainnet launch. Our mainnet launch was in October. So we really needed to bootstrap the ecosystem and get a bunch of developers in to build stuff on top. So how do you do that? Well, you build example apps, right? So we made NFT. NFTs were really hot at the beginning of 2021, obviously. So we made our NFT standard. We worked on that together with a whole bunch of people, not just me, just a whole bunch of smart people, you know, bring them into the room, big Zoom calls, and just sort of hammer out what should the general kind of code, the templated code for NFTs look like. And the reason why you try to come up with a standard for things like fungible tokens and non-fungible tokens is because they're used everywhere inside applications. Like fungible tokens, basically a fungible token smart contract is basically like having a Bitcoin inside a smart contract platform. And now you can have many Bitcoin types. So you can have, you know, token A, token B, token C. Non-fungible tokens, I mean, everybody kind of knows what they are. So basically just unique versions of tokens. So that's standards help apps talk to each other, so that like a wallet, for example, which is just a front end kind of application that sits on top of the blockchain, can actually understand like, oh, you know, Troy has all these different kinds of cool tokens, like fungible tokens and NFTs. Awesome, cool. I'm going to show them to them. So standards help basically all sorts of apps and other sort of utilities and stuff on blockchains talk to each other. And then there's this concept of like composability as well. So it's very hard, like try going to like, you know, 3 different types of Lego kits or even Lego style toys across different companies, and then try snapping the pieces together. It just won't work, right? So that's also what standards give us. They give us composability. We can actually snap together applications, and there's very interesting and creative applications built on top. My favorite example actually was back in the day, like after these NFTs launched called CryptoKitties. If you haven't heard of them, they were like the biggest NFTs at the time. There was a company like just a few months later, like called like Crypto Dragons or something. And they basically said, if you take your CryptoKitty and you send it to this smart contract, which was essentially basically going to end your CryptoKitty's life, like by basically having it locked inside the smart contract. They said, if you can send a transaction of a CryptoKitty to this smart contract, we'll create you a crypto dragon. So it's basically like the dragon is eating the kitty, right? And the thing is, because CryptoKitties are owned by users and they can send them wherever they want, there was nothing that like the CryptoKitties people could do to stop this like killing of their kitties and feeding them to dragons. So it's a little morbid, but it was it's a great example of like the permissionless aspect of composability as well. So you can't, once you launch a token, you can't stop people from saying, hey, if you got Troy's token, come over to my app. I'll give you these other tokens instead. You know, send me all of Troy's tokens and I'll dump them, and then I'll give you this new token. So there's nothing you can do to stop it, which is actually kind of interesting. Yeah, so I touched on a bunch of stuff. Anyway, so I was at near developer relations for a bit, and then I actually spun out to start. I started an NFT company with some people from near, but I wasn't. My interest in NFTs is sort of starting to wane at this point. I've spent so much time, even when I was in Ethereum, I spent time working on NFT standards over in Ethereum. I wrote some standards. They're not like fully ratified or whatever, but they've been used all over the place by applications. So, I mean, I've just been around NFTs for so long. So now I'm actually with a team. The latest, current post is basically I'm with a team called Proximity Labs, and what Proximity Labs does is they help get DeFi applications building and stuff and launching on what we call the near virtual machine, or we call it sometimes the near native runtime. So what that means is that there's this aspect of near. So near is a blockchain. It's one blockchain at the very base of it that agrees on the next sort of state update. The near native virtual machine will talk directly to that blockchain and make storage update, make state updates and stuff, typically kind of using storage and stuff. But that's the near native virtual machine. It's usually written in Rust contracts that compile down into WASM, which stands for WebAssembly. But basically all you need to know is that that's near native. And then there is one other kind of environment that you could launch your things on, which is, I don't know if anyone can guess it. It's an EVM environment, obviously, because Ethereum is so popular and so big. There's a lot of developers that know how to write code that actually works in an EVM environment, an Ethereum virtual machine environment. So Aurora is actually the name of that team. And that team is also separate from Near, like I am. And that team is solely responsible for basically providing the best and the best sort of execution environment for these Ethereum smart contracts. So developers can go, they can deploy to the EVM on Aurora, and everything just works, which is awesome. So you can, if you're coming from an Ethereum background and you're just kind of tinkering around, just try out the Aurora testnet, try out the Aurora mainnet even, because it's so cheap. And then Proximity Labs, where I work, we focus on getting DeFi products on basically the near native runtime. So there's obviously a learning curve to come into a new blockchain with a new way of doing things, a new way of maintaining that contract state and that sort of ledger of accounts and balances. So we help developers with the code. So we do a lot of like research and development. We help with a lot of, we're still working on like wallet interoperability. So things like having MetaMask, for example, runs on Aurora because it's EVM, but we also we're working on right now having MetaMask work on the near native virtual machine. I already tweeted about it, so it's okay. So yeah, things like that. So we're like deep in these projects, auditing contracts, getting grants to developers that are building on the near native VM. And then also when it comes to DeFi, new DeFi projects need to bootstrap something called liquidity. So basically they need to have early capital like in their protocol. Otherwise, no users will come. So if it's sort of a lending and borrowing platform, well, there needs to be somebody lending before there can be somebody borrowing, right? So Proximity will actually, it sort of stewards some funds and will actually kind of move in an appropriate amount of liquidity at the beginning just to get the wheels spinning so that we can have like a healthy kind of borrowing and lending market. Yeah, so happy to answer any questions. Sorry for the ultra long intro, but I was picking up so much of what Troy was saying, and I was listening to his great presentation, and I just thought I'd like kind of echo back to some of those technical points as well as I introduce myself.
Yeah, no, that was awesome. Thank you for sharing all that. I learned a lot just now. I'm sure everybody else did as well. Yeah, if you have any questions for Matt, feel free to put them in the chat. I have a question for you. So
Sure.
I'm a computer science student. Like I'm passionate about blockchain. I'm trying to, I would like to work in the space. Like what advice do you have for someone who's looking to break into the industry in terms of like a real paid position or maybe start their own business? Like what advice do you have as someone who's successfully done this? What advice do you have for someone looking to do that?
Yeah, so breaking into just like the Web3 side of things, as opposed to going to the job fair and like signing up with Microsoft.
Yeah, because for instance, I went to a job fair a few weeks ago in my school. I talked to every single employer there, and none of them were blockchain companies, and I was disappointed. So, there's a lack of representation in some of those things, and the path towards working in this industry is not so clear for some people who are familiar with the traditional path.
That's a great point. A lot of these blockchain crypto companies, they're remote and they're operating online, and they're pretty accommodating in that sense, which is good. So you kind of it is hard to break in. And also like all these crypto and blockchain companies, at least the good ones that I know about, they don't have LinkedIn, like they don't do any of this stuff. So what you really have to do is I would highly recommend, you have to actually you have to like jump out on Twitter, and you have to start following some of the major companies in the space. I don't exactly, I do. So here's how you would find out who is good to follow on Twitter. And also, just before I say anything, this space, because it's so early, it's so new, and it is kind of like the Wild West, there are a lot of scams and a lot of crap. I'm sure, like, with the UNF and the BAF and everything, you guys have been warned about this, but just when you go follow a bunch of people on Twitter, just make sure that they're quality people. Even somebody like an influencer that's just basically like, this person bought, a bunch of tokens a long time ago, and they're just trying to quote unquote pump their bags, which is basically saying that they're just promoting coins that they have so that you buy them, so the price goes up. You have to be very, very, very skeptical of all of this stuff. So that's one thing I want to say. That being said, you should jump out onto some really good resources that are put out by, the large venture capital firms that are entering the space, that are putting a lot of money into this space. So things like A16Z has like a crypto canon reading list. They also have like an NFT reading list. When you go, there's literally hundreds of articles. I'm on the crypto canon, by the way. It's a little plug for me. So when you go through that list, you're going to see all these articles. Now, click on the article. It's usually like 90% going to land you on Medium. And right next to the author's face is a little Twitter bird. So click on the Twitter bird, follow that person. So basically what you want to do is you want to try, like in school, when in like an arts degree or whatever, they tell you to go to the first sources, right? So you want to actually try to get to the people that are building the blockchain. And another great way to do it is to go to all the top blockchains, except for maybe some of the ones in the top 10 right now, like, no Cardano, no Ripple, please. You could stay away from the Binance stuff. I mean, sorry, Binance, but, we want some real public blockchains out there, right? So basically, like blockchains like Near, even I would say, I'm not too tribal here or too maximalist, but follow as much of the Ethereum people as you can that are building the actual core blockchain. Follow the Avalanche people like Emin Gunser, like he was an ex-professor of Cornell, smart guy. Follow him. Follow all of the co-founders and founders of all the blockchains. Go to their team pages if they have them, and basically cruise through the top 20 people and see if they have Twitter, and just Google their name, find their Twitter. So I'd say go to like the first sources, go to the people that are actually building the chain. And then now, how do you actually turn that into getting a job? Well, watch the conversation, right? Like watch what your Twitter feed starts to do and the news that it starts to show you. Take 15 to 20 minutes a day to just scroll. And when you start to see things that pique your interest, start to engage. And then eventually you'll find that as you kind of see things tweeted and retweeted by other people, and you follow followers and follow, you know, you're going to build up a pattern of things that you're interested in. And then you can actually reach out and engage with those people on Twitter. So you can actually, a lot of people have their direct messages open, or their DMs. So you can slide into their DMs and like, you can just ask them, hey, I saw that you're working at such and such. Please read the person's profile, like bio first, or at least try to Google their name. Because I have so many people that are messaging me about like stuff I did like ages ago. So it just like, it's kind of an insult when somebody's like, hey, I saw you're working on this Ethereum standard. Can you help me with my Ethereum smart contracts? And I'm like, I have not wrote an Ethereum smart contract for like 3 years. So no. But yeah, so make sure you're up to date on the people, you're finding patterns of people that you like, build that Twitter list with good first sources, and just get out there. Yeah. And also another way to like tactically hone up your skills is to produce good public like open source software on GitHub. So if you're a developer, you basically would, if you're interested in stuff, go fork the repo, you know, clone it to your local machine, make some changes in a branch or whatever, and try to like change the smart contracts to how they work and stuff. And then go find the developer. If you want to be a developer at a crypto company, go find the developer that made that example and say, hey, I was doing something, I thought your example was really cool. I was doing something interesting over here. A good entry level job for like a crypto company that's awesome and easy for you to grow and learn a lot of things is developer relations. So basically building examples, cleaning up the docs, talking to other developers, trying to build on that chain. You will get literally plunged into basically having to learn that blockchain inside and out super fast, and helping other developers do so. So anyway, those are my tips. We have time for 0 more questions.
Okay, yeah. We're coming towards the
but
end.
It's okay. It's okay. I can keep going for a bit if it's.
Well, yeah, definitely. There's a lot of really great information there. I really enjoyed hearing you talk about some of the subjects in regards to what you're doing within the crypto ecosystem. And thanks for giving those tips for, I know there's a lot of people watching who are interested in breaking into the industry or actively trying to do so. So coming from someone who's done that and is working in industry right now is great to hear from. So thank you.
I also have a list that I will share. I have a list that I maintain called Top CT, and that's top crypto Twitter, and I'll put that in the chat. And I just have like, it's 176 accounts. You can just click on the list and follow the list itself, or you can start going through the accounts and picking the ones that you want.
Awesome. I'm probably gonna have to do some mass following after this. Hopefully Twitter doesn't stop me.
Yeah.
All right, cool. So yeah, we are reaching the end of the session. Thank you so much, Matt, for joining us here today. And thank you to everybody else for watching the presentation. I hope you guys all learned something useful. So yeah, also to conclude the account creation activity, everybody who sent funding addresses to the Google Forms that we posted earlier should have received Near by now. And so you should be able to go in there and create your human readable address and start interacting with the Near protocol. So yeah, that pretty much does it for today. I want to thank everybody for coming, to our special guest speaker, Matt, Natasha, Cutter, Alex, Bath for putting it on. Everybody we're working with at Near and everything. You guys are all awesome. And thank you guys so much, and hope you guys enjoy the rest of your weekends.
Join Web3.
Yeah.
Definitely.
All right.
All right. See you guys. Thanks.
All right. Thank
Thank
you
you.
very much.